Good afternoon, everyone. Today, our group will be presenting how to collaborate V naught so that we can find out the coefficient of discharge. Next slide. So, before talking any further, we'll have to get acquainted with what is a notch. So, a notch is an opening in the side of a measuring tank or a reservoir through which the water can flow over the free surface. Talking about the geometrics of the knots, the bottom of the part is called crest, and the flow of a thin sheet of water is called nepe. So, how is discharge measured? So, discharge is measured by measuring the head acting over the notch. So, as the water approaches the notch, its surface gets a little bit curved. So, it can get a bit of inconsistencies. So, what we do is we use we use the area over which the effect of curvature is minimum, and we calculate the head over that point. Next slide. So let's talk about types of notches available. The first is V notch, the one which we are studying, and it is also called a triangular notch. It is used to accurately read low discharge values, and another is suppressed rectangular notch, rectangular notch, circulative, which is another name for trapezoidal notch. The further experiment will be explained to you by Gopal. Thank you.
Hello, everyone. Now I'm gonna discuss about V notch. It is sharp rest notch made of metallic plate, which is mainly used to determine low rate of flow. This notch was installed at the exit of the channel in order to measure the real-time flow of water. It is generally used to measure flow rate in an open channel flow. The theoretical flow rate is given by 8 by 15 CD under root 2G multiplied by 10 theta by 2 s raised to the power 5 by 2, where h is the height of the liquid above the apex of notch, theta angle of notch, and Cg is coefficient of discharge. Next slide. Now I will discuss apparatus in notch. Channel is used to pass the water. Hook gauge is used to measure change in water level due to evaporation. Piezometer Piezometer is used to measure water pressure by measuring height of rise. Collecting tank is used to collect the water. Further, Deepika will explain the procedure part.
Good afternoon, everyone. Now I'm going to discuss the overview of this procedure. In this experiment, firstly we will start the motor with the help of which water will flow in the open channel. From the open channel, water will flow to the V notch from where we will calculate our height h. From V notch, the water will go to the collecting tank in which we will calculate the time taken for the rise of water. Repeating this procedure 3 to 4 times, we will calculate average coefficient of discharge of V notch. Now we are going to discuss this experiment with the help of a video. This is the experimental setup which will be used in this experiment. This is the motor. This is the water reservoir. This is open channel. At the end of this channel, there is a V notch. This is the water tank in which water will flow from the V notch. This is scale to measure water in open channel, and this is scale to measure water in collecting tank. Now water is flowing from the channel to the V notch. Height will be measured from center of the notch to the water level. Now further this will be explained by Ishu.
Now we are going to calculate the discharge of water through V notch. This is collecting tank whose dimensions are 14 to 36 centimeter. Now we will note down the time taken for the rise of 10 centimeter of water. For the first reading it comes out to be 10.01 centimeter, and with the help of this we will be able to calculate the volume of water and hence the actual discharge. This is the water flowing through the open channel, and you can look here the water flowing through V notch and coming into the water collecting tank. Now coming on to the observations, in the first column you can see the initial reading, which is the water level at the crest. In the next column, final readings of the water. And by subtracting these both, we we get total head, which we have found in the third column. Now talking about the theoretical discharge, which is equal to 8 by 15 into under root 2g into tan theta by 2 into h raised to power 5 by 2, where g equals to acceleration due to gravity, theta equals to angle of the V notch, and h equals to rising height of water in the collecting tank. Now Q actual equals to volume of the water in the tank by time taken, or area into height by time, and discharge coefficient equals to actual discharge upon theoretical discharge. Now further experiment will be explained to you by Ashdeep Singh.
Now a graph is plotted between actual discharge and total head using 6 values. The equation of graph comes to be of form y is equal to kx raised to power n, where k is equal to 20.62 and n is equal to 2.2934. Now result, average discharge coefficient is 0.63. Now moving to precautions. Note down the mean value carefully as there is fluctuation in the piezometer tube. Note all the readings carefully and maintain constant discharge in each reading. That was all about today's presentation. Thank you.